Hello, today we focus on speed and accuracy in mathematics. Speed and accuracy are very important as far as solving of problems in mathematics are concerned, especially during exams. Most of the time you hear students talking about the exam being easy, but there was the problem of time. So today we look at shortcuts for fractions because fractions are one of the important speed breaks that you come across each time you are solving problems in mathematics. In the first situation, we look at shortcuts that we can use to add and subtract fractions. In the first case, we have a all over b plus or minus c all over b. The characteristic here is that the denominators are the same. Once that happens, you only concentrate on the numerators, adding or subtracting, and then putting all over the common denominator. So here I simply get a plus or minus b, plus or minus c all over b. An example would be 3 all over 5 plus 4 all over 5, and the answer is simply 7 all over 5. You can also have negative 2 all over 7 minus 8 all over 7. I concentrate again at the numerators. Negative 2 minus 8 is negative 10 all over 7. You can even have a situation where it occurs with mathematical expressions. You have, for instance, x all over x plus 2 plus 3x all over x plus 2. That simply gives x plus 3x, which is 4x all over x plus 2. In the second case, which is the most common, we have a all over b plus or minus c all over d. The tendency here is that students try to look for the LCM, and sometimes the LCM is not easy to come by. When you arrive here, you do not need to look for the LCM. Simply do a cross AD plus or minus CB all over the product of the denominators. So I simply get AD plus or minus CB all over BD. Whatever the case, this product might not be the LCM, but at the end you gain time, because once you have evaluated the numerator and then divided by the denominator, you will simply simplify, you will simply cancel, and then get the final result that you would have obtained if you had found the LCM. Examples here, we could have 3 all over 4 plus 5 all over 7. I simply cross, I get 21, plus I cross, I get 20 all over the product of the denominators, which is 28, and my answer is 41 over 20. I could also have 7 all over 15 minus 11 all over 20, and that gives me 140 minus 165 all over 300. This gives negative 25 all over 300, which now simplifies to negative 1 all over 12. It can also happen with mathematical expressions where you have 3 all over x plus 1, for example, minus 4 all over x minus 1. This will give, I cross, 3 into x minus 1 minus 4 into x plus 1 all over x plus 1 into x minus 1. This gives 3x minus 3 minus 4x minus 4 all over x plus 1 into x minus 1. Once you arrive here, never touch the denominator again. You only expand the numerator and then simplify. So in the last step, I get negative x minus 7 all over x plus 1 into x minus 1. The third case of fractions, we have a whole plus or minus a fraction. Although it still resembles this one, I just need to put over 1 and do the crossings and so on. But I could simply just multiply the denominator by the whole, then add the numerator. So it gives AC plus or minus B all over C. An example would be 5 minus 1/3, which is simply 15 minus 1, and that gives 14 all over 3. Very fast. Negative 7 minus 2/3 gives negative 21 minus 2, that is negative 23 all over 3, and so on. If I had x plus 1 all over x plus 1, I will get x into x plus 1 all over x plus 1. This gives x squared plus x plus 1 all over x plus 1, and so on. The next situation we look at is division. Division of fractions. Under division, you could have the first case where you have 1 divided by a fraction. Here, most students do not know that 1 over a fraction simply means the inverse of the fraction. So you invert the fraction and you simply get b over a. Turn the fraction over. So if I have negative 1 all over 4/5, the answer is negative 5 over 4. If I have 1 all over x plus 1 all over x minus 2, the answer is simply x minus 2 all over x plus 1. In the case where the numerator is not 1, you simply take that numerator and multiply by the denominator down, then over the numerator that is down. So C times B over A is the shortcut. CB all over A. An example includes 3 all over 5 on 4, which simply 3 times 4 divided by 5 gives 12 all over 5 directly. Another example could be negative 2 all over 4/7. It gives negative 14 all over 4, which could now be negative 7 all over 2. In another situation, we could have a fraction divided by another fraction, and the denominators are the same. You simply cancel the denominators. Over b cancels over b, and you are just left with c over you are just left with a over c, sorry. So example, 3 over 5 divided by 4 over 5 over 5 cancels over 5. The answer is 3 over 4. It can happen with mathematical expressions too. X all over x plus 5 divided by 4 plus x all over x plus 5 over x plus 5 cancels over x plus 5, and I'm just left with x all over 4 plus x. In another case, we can have a over b divided by c over d. In this case, I simply say the top times the bottom over the middle times the middle. So I get AD all over BC directly. Example, 3/5 divided by 4/8. This will be 3 times 8 all over 5 times 4. So it gives 24 all over 20, which you can then simplify by cancelling 4 to have 6 all over 5. It can also happen with mathematical expressions. If I have x all over x plus 1 divided by 2 all over x plus 2, I simply get x into x plus 2 all over 2 into x plus 1. And then finally, you could have a situation where there is 1 all over 2 minus 1 all over x plus 1 to simplify. In the next step, I work out the denominator. That gives 2 into x plus 1 minus 1 all over x plus 1. And so in the next step now, this will give me 2x plus 2 minus 1, which is simply 2x plus 1. And I invert it, I now get x plus 1 all over this numerator, which is 2x plus 1. And you see your speed going very fast.